Okay, so 10.1 we're going to learn some sum and difference formulas for sines and cosines. And the first one we're going to look at, which will allow us to derive the other four, is we're going to look to derive a formula for the cosine of alpha minus beta. And one thing you might be wondering is, gee, does something like the cosine of 60 minus 20 equal the cosine of 60 minus the cosine of 20? And I'll let you work that out on your own, that's not the case. So there's got to be another formula here, and we're actually going to derive it. To do that, we're going to locate our angles alpha and beta conveniently on the unit circle in standard position. So here I'm going to rotate up, and here's my angle beta, and here I'm going to rotate over, and here's my angle then alpha. So the angle alpha minus beta is going to be this angle right here. And I can label, since I'm on the unit circle, I can label the endpoints for my beta and my alpha. Cosine beta, sine beta is going to be on the unit circle, my x and y coordinates there, and ditto over here, cosine of alpha, sine of alpha. Next, the key for this, what we're going to want to do is we're going to want to draw in this line here, and we're going to call that line A, B. And we're going to figure out two ways that we can find that length, the length of that line segment AB. Now remember, my angle here between these two rays is, again, going to be alpha minus beta. I've got a triangle here with, if I'm the unit circle, a 1 and a 1, and I've got this third side of the triangle out here. What are the two ways that I can find this length? Well, one way simply would be the distance formula, distance between A and B. The other way to find that angle would be to note that we have an included angle here, alpha minus beta. We have a side of 1 and we have a side of 1, so we can use the law of cosines to find this length as well. Well, if we use the distance formula to find the length, or if we use the law of cosines to find the length's going to turn out to be the same. So we're going to find the length two ways, set those two values equal, and see what comes out. That's the strategy. So by the distance formula, by the law of cosines, AB squared is going to equal 1 squared plus 1 squared minus 2, 1 times cosine of alpha minus beta. Aha, we were trying to find a formula for the cosine of alpha minus beta. And there it is. We can then simplify this, and we get that to be 2 minus 2 cosine of alpha minus beta. So that's method 1. Method 2 is to use the distance formula, and the algebra gets a little nastier. But here we go. Distance formula, and if I want to find AB squared, and note when we use the law of cosines, we actually were finding AB squared. So I'm going to use the distance formula, but I'm actually going to find AB squared with the distance formula. So that's simply going to be the difference of x coordinates for AB squared plus the difference of y coordinates quantity squared. And when I expand that, and unfortunately I do have to expand that, I get cosine squared alpha minus 2 cosine alpha cosine beta plus cosine squared beta, expanding the other, plus sine squared alpha minus 2 sine alpha sine beta plus sine squared beta. And note what happens here. We've got a cosine squared alpha plus sine squared alpha. We have a cosine squared beta plus sine squared beta. Sine squared plus cosine squared equals 1. So we get a 2 out of that. And then if we combine the other two terms and we factor out a negative 2, we get 2 minus 2 times cosine alpha cosine beta plus sine alpha sine beta. And that is what AB squared is equal to. So then we look and say, well, now wait a minute. We got an AB squared up here that turned out to be this, and we got an AB squared down here that turned out to be that. So let's set them both equal. We'll go to a new slide to do that. So I go ahead and set those equal, and note what happens. My 2's are going to cancel. I can divide both sides by -2, and I'm left with the cosine of alpha minus beta equals cosine alpha, cosine beta, plus sine alpha, sine beta. And there's my formula for the difference of the cosine, the difference of two angles, cosine. Do you want to memorize that? Indeed you do. That's one you want to memorize. So suppose we want to come up with a formula for the cosine of alpha plus beta. Well, we could view that. We know what the cosine of alpha minus beta is, so we could write cosine of alpha plus beta as the cosine of alpha minus beta and simply use our cosine of alpha minus beta formula, because cosine of alpha minus beta is the equivalent of cosine of alpha plus beta. So go ahead and use the formula we just derived. This then would be cosine of alpha times cosine of negative beta plus sine of alpha times sine of negative beta. Well, what's the cosine of negative beta? The cosine of negative beta from chapter 8 was the cosine of beta. So this is cosine of alpha, cosine of beta. Now over here, the sine of negative beta is the negative sine of beta. So let me take the sine of negative beta. We'll rewrite that as the negative of the sine of beta, and we're just going to put that negative sign out front. So it's going to be cosine alpha cosine beta minus sine alpha sine beta. Or in other words, the cosine of alpha plus beta equals cosine alpha cosine beta minus sine alpha sine beta. Again, do you want to memorize this? Is this one of our formulas we want to memorize? Indeed it is. So if we want to derive formulas for cosine of alpha plus beta, cosine of alpha minus beta, you should be thinking, well, of course then we are going to be interested in finding a formula for example, the sine of alpha plus beta. And indeed we want to go and do that next. And to do this, we're going to use one of our cofunctions from chapter 8, that the sine of an angle is the cosine of the complement. Remember our cofunction identity. And also we're going to let theta here be alpha plus beta, because remember we're looking ultimately to find the sine of alpha plus beta. So I'm just going to go ahead and make a substitution and say let theta be some alpha plus beta. So our next step then would be to say that the sine of alpha plus beta equals the cosine of pi over 2 minus alpha plus beta, and I'm going to group that alpha plus beta together as follows: minus alpha plus beta, like so. Go ahead now and rewrite this as sine of alpha plus beta equals the cosine of, I'm just going to rearrange my parentheses, cosine of pi over 2 minus alpha minus beta. And then note what we have here in this expression. We have a cosine of an angle minus an angle. We have a cosine of an x minus y, and we just derived a formula from that previously. So we then can go ahead and use our cosine of x minus y to rewrite this expression as the cosine of pi over 2 minus alpha times the cosine of beta plus the sine of pi over 2 minus alpha times the sine of beta. And then we're going to use our cofunction identities. The cosine of pi over 2 minus alpha is the sine of alpha, cosine of beta, plus the sine of pi over 2 minus alpha is the cosine of alpha and sine of beta. And indeed, the sine of alpha plus beta equals sine alpha cosine beta plus cosine alpha sine beta. There's another one. Again, do we want to memorize? Yes, you want to memorize. So we just derived a formula for the sine of alpha plus beta. Clearly, we're going to want to derive a formula for the sine of alpha minus beta, and we'll do that by rewriting alpha minus beta as alpha plus negative beta and use the formula we just used up here. So if I do that, I get sine alpha cosine of negative beta plus cosine of alpha times sine of negative beta. And we remember that the cosine of negative beta is the cosine of beta, and the sine of negative beta is the negative sine of beta, so that's going to be minus cosine alpha sine beta, or in other words, the sine of alpha minus beta equals sine alpha cosine beta minus cosine alpha sine beta. So there are the four formulas for the difference of sine and cosines. And let's take a look now at a couple of problems that you might be asked to do. What type of problems you're going to be working with this. So suppose you were asked to state an exact value for cosine 70 degrees, cosine 10 degrees, plus sine 7 degrees, sine 10 degrees. You've got to recognize that you're looking at here a cosine of angle, and if this is a plus, angle minus angle. So this actually is then going to be a cosine of 70 minus 10, or a cosine of 60, and my cosine of 60 is 1/2. So suppose you want to give an exact value for the sine of 75 degrees. I know 75 can be broken down into 30 and 45. It can be broken down in other things as well, but I'm thinking 30 and 45 are some things I know about. So this could be a sine of 30 plus 45 degrees. And I know then that I can use the sine of the sum of two angles to rewrite this as sine of 30 cosine of 45 plus cosine of 30 sine of 45. Sine of 30 is 1/2. Cosine of 45 is root 2 over 2 plus cosine of 30 is root 3 over 2, and sine of 45 is root 2 over 2. Simplify root 2 over 4 plus root 6 over 4. Simplify root 2 plus root 6 over, whoops, that should be a 4 there, sorry, over 4. So let's take a look at one more example. We'll take a look at example problem number 28 on page 373. And they tell you you've got two angles, alpha and beta, and they're between pi and pi over 2. So I know those two angles are over here in this quadrant. And in that quadrant, their cosine's negative and their sine's positive. And I'm interested in finding the sine of alpha minus beta. And I'm given some information. I'm told that the sine of alpha is 4/5. And I'm told that the sine of beta is 1/2. So the first thing I'm going to think about is, hey, I've got a formula for the sine of alpha minus beta, and I'm going to write that down. That's sine alpha cosine beta minus cosine alpha sine beta. So what this boils down to is, can I find, let's see, I've got the sine of alpha, I got the sine of beta. That's pretty easy. Can I find the cosine of beta if I know beta is in the second quadrant and has a sine of 1/2? And can I find the cosine of alpha if I know if the sine of alpha is in that second quadrant and has a sine of 4/5? And the answer is, of course I can. This is a review problem to some degree. Set up your alpha here. You know it's going to be somewhere here in the second quadrant, and you know your sine is 4/5. So go ahead and create a 4, 5 with your right triangle, and then your missing piece, you know that's going to be a -3 because it's a 3, 4, 5 triangle. And then go ahead over here for your beta. You're going to set up into that second quadrant over here somewhere, and you know your sine is 1/2. Well, create your triangle, 1 and 2, and then you're going to have a -√3 here. And then then you can simply answer the question. You're doing arithmetic from now. What is the sine of alpha? Well, the sine of alpha is 4/5. What's the cosine of beta? The cosine of beta is -√3 over 2 minus, what's the cosine of alpha? Cosine of alpha is -3/5. And what's the sine of beta? The sine of beta is 1/2. And then you're simply going to go ahead and simplify that out, being very careful with negative signs, and you wind up getting, in the end, you should wind up getting 3 minus 4√3 over 10. So that should get you through, pretty much through problems 1 through 30 or so in section 10.1. Read the other examples in the book, but that should get you through.